Hi friends, this video we are going to see complex integration and how to evaluate it. Okay, this our topic is complex integration. So we already know about what is the real value integral. The main difference in R and C are R is a ordered field. But C, that is complex number system, is not an ordered field. Suppose you have the two numbers. In R you can compare which is the greater than, which is less than. But in C you cannot compare which is lesser, which is bigger. Okay, so that is why whenever you write it, suppose I choose the real value integration A to B, I know which way I want to do it. So I clearly know that A is less than or equal to B. But if I give the complex number system, suppose Z1 to Z2, f of Z, dz. Suppose I simply see this is the complex integration of these 2 points I want to find. What will become? Please check. This is the point Z1. This is the point Z2. So Z1 and Z2. How many ways I can choose? I can choose this is the first way. Second way I choose this directly. And third one is okay, so many ways you can approach here one point to another point. So that is why whenever we require the complex integration, we require which way we want to choose. So which curve. So we say along the curve. So you already know that what is the curve, everything. So now I start with what is the complex integration. Definition I choose first. Let C be a piecewise differentiable curve. Given by the equation z of t, here where t is some real number, so it has some interval a to b. Okay, let f of z be a continuous complex valued function defined in a region that region is containing the curve C, this curve only, okay, containing the curve C. So then we define integral over f of z over the curve C dz equal to, so now I will convert to the real value types integral, that is a to b f of z of t times z prime of t dt. So here z of t is the curve equation. The curve C. Okay. Now we see what is the few examples. It will help you to understand clearly. So first see one example. Consider integral over C f of z dz, where f of z is equal to 1 over z and C is the circle mod z equal to R, described in the positive the parametric form of the circle mod z equal to R is given by so I require the z of t, that is, so I require z of t equal to x of t plus I times y of t. Suppose the given means we can write it as x equal to r times cos t plus I times r times sin t, where t lies between, because it is described in the positive sense, so it's the anti-clockwise direction. So t lies between 0 to 2 pi. It's a closed interval. Let's say full circle they require. Okay, so this one. So now this way we can proceed. Then what this is z of t, I can write it as r times cos of t plus I times sin of t. So from the Euler formula, so I can write r times exponential of it, where t belongs to closed interval 0, 2 pi. So now I want to integrate over this curve. Okay, integral over C f of z dz equal to integral over a to b f of z of t times z prime of t dt. This is from the definition. Here what is the a? So in our problem, a equal to 0, b equal to 2 pi and f of z equal to 1 over z and z of t equal to r times exponential of it. Then z prime of t is I times r times exponential of it. So then integral over mod z equal to r f of z, that is 1 over z, correct? 1 over z dz is nothing but integral over 0 to 2 pi f of z of t, that is 1 over r times exponential of it times z prime of t is I times r exponential of it times dt. So this is simply now real integral only. I can cancel out, so I will get it as I times integral over 0 to 2 pi dt. So if you are integrated, you will get it as t, then upper and lower integral you apply, you will get the 2 pi I. This is our first example. Now we are going to the second example. So this is a very simple circle, so easily we can find the parametric form. Correct? Suppose line segment, what will come? That is why we are going to the another example. So find integral over c f of z and dz. Okay, where f of z equal to y minus x minus I times 3x square. Okay, this is my f of z. And what about the c? Another thing I require is and the curve c. C is the line segment from z is equal to 0 to 1 plus I. So z1 is 0, z2 is 1 plus I. So what is my aim is, now I want to find the parametric form. How to find it? So the keyword is they give the line segment. So it must be a line. So using that idea, this is the curve, this is the complex number. First point is 0. This is 0, 0. And second point is 1 plus I. This is 1 plus I. This is 1 plus I. This point is 0, 0. So they give the sum on line segment, correct? So that is the line segment is, this is the my line segment. So I want to find it. How I can find? So suppose you see in R2 mean this one, what will come? That is, so you want to find y equal to mx plus c. Similarly, you want to find what is the formula for m is y2 minus y1 divided by x2 minus x1, and that curve is passing through the origin is origin only, so automatically c become 0. Yes. So then y2 is 1, y1 is 0. So m equal to 1 divided by 1, that is 1 only you will get. Then y equal to x. C is 0, it's an obvious case because in this curve is already in 0 is 0 only. If your input is 0 and y is also 0, that is why C is 0, so we find that y equal to x. Now you want to convert in the parametric form in terms of t. So you take x equal to t, y equal to t, and the t is lies between 0 to 1, correct? So 0 to 1. This is the my parametric form for x and y. Now we see. So z of t equal to x of t plus I times y of t. That is, x of t is t plus I times y of t also t. Here t lies between closed interval 0, 1. So integral over c f of z dz is integral over 0 to 1 because my a is 0, b is 1. What is my f of z is y minus x, that is t minus I times 3 t square times z prime of t is nothing but we get 1 plus I dt. So I will slip it, because I know that what is x of t is x of t is t. So that is why y is also t, x also t. I simply apply this result. And z prime of t is, to take derivative with respect to t, you will get 1 plus I. Now this is the equation. Now you multiply, you will get it as this t and this t will cancel. This t and this t will cancel. So I will be there. So this is 1 plus I is a constant. So I will take it as a 1 plus I is outside. Integral over. So minus I also I take outside. So integral over 0 to 1 3 times t square dt. So if you are integrated, the t cube will come. So you will get that 1 minus I. You will get the answer because this guy is simply you will get as 1. This integral value is automatically become 1 because t cube by this is equal to 1. This is equal to 1. So this guy is only will be there. So I multiply minus I square is minus 1, outside is minus, so it will become 1 plus I. Fine. Now we see one more problem. So first example we see the circle, second is line segment. So now in this problem we are seeing two piecewise curves joining. That's it. So, okay, that is my third example. So evaluate the integral. Integral over c z bar times dz from the point z is equal to 0 to z is equal to 4 plus 2y along the curve C. The curve C. The C curve consisting of first one is of the line segment z is equal to 0 to 2y. Z is equal to 0 to 2y. Then followed by another line segment segment from z is equal to 2y to 4 plus 2y. So now this is a, so first step I want to find what is the parametric for C. To find the C, what is the given is they give the two line segment, correct? So they give the two line segment. The first, this is the point is we choose as first point is 0. The next point is 4 plus 2y. This is the 4 plus 2y. Now I need, so but what they mentioned, they have the first alignment segment is 0 to 2i. So 0 to 2i means this is 0 to 2i. Then 2i to 4i. The first curve is 0 to 2i. And the second curve is 2i to 4i. This is the way they make it. Okay. So this is our C. This is my C. Okay, my curve. So how to find here? First I want to say, I will take this is C1 and this C1 is C2. I will take it. So my curve C is C1 plus C2. Like our previous example, y2, first I will go for the parametric for C1. The for C1, y1 is 2, y0 is 0, x1 is 0, x2 also, x0 also 0. That is also, this curve also passing through the origin is y is x is 0 means y also 0. So line segment is 0. So y equal to mx plus c, m equal to infinite. So that meaning is x throughout the x is constant. X equal to 0, y equal to t. T lies between 0 to 2. Correct? This implies my z of t equal to I times t. Then z prime of t is simply I in the along the curve C1. So what is the f of z given is? F of z is z bar. So my f of z is z bar, that is x minus I y. Correct? So now I want to first integral C1 f of z times dz is nothing but integral over C1 z bar times dz. So along the curve parametric form, what is the x value lies between, t value lies between 0 to 2. So 0 to 2, f of z of t is z bar, that is x is value is 0 only along this curve C1, y value is t. So then you will get it as minus I times t, z prime of t is I times dt. So you will get it as t square divided by 2 and 0 2, you will get it as 2 only. So the first curve along the curve C1 is, you will get it as 2. The second curve I want to find. What about the second curve is? The first point is 0 plus, this point is 0 plus 2i, this point is 4 plus 2i. Here also the y axis is, y is always fixed, the y is constant, correct? It's parallel to the x axis. So that meaning is, in along the curve in C2, y value is, parametric form y is 2i and the x is varies from 0 to 4. This is the clear idea. So the parametric form the C2 is, z of t is, x of t is t plus, so y is 2 only, not 2i, because it's along the, so y is I times 2 or 2i, where t belongs to 0 to 4. This way only I find. My next step is what I want to try. I want to find the integral over C2 f of z times dz. So this curve is C2 is 0 to 4 and the fz bar t means t minus 2y times, if you take the derivative, you will get it as 1 times dt. So if you are integrated, you will get it as 8 minus 8i. This is the, so but my piecewise I found, so I know the result from integral over c f of z dz equal to integral over c1 times f of z dz plus integral over c2 times f of z dz. This implies, first I found the integral value is 2, second integral is 8 minus 8i, so I will get it as 10 minus 8i. This is the evaluate the integral of z bar over the along the curve C. I hope you will understand the complex integration, how to evaluate the complex integration. Thank you for watching this video. Suppose you have any doubts, please post in the comment box. Thank you.